I listed out all the steps from last lecture. So what's the first step? Oh, no reaction. I think I listed out all the steps, guys. I
Make a
gave you this
substitution.
procedure. What's step number one? Replace or make a substitution. T equals to x minus a, right? Okay, so in this case, what am I going to get? T equals to what? What is t equal to in this problem? A is minus 1. So what is x minus a? The center is at minus 1. So what is x minus a? X plus 1. Thank you. So t equals to x plus 1. From here, it implies that x is equal to t minus 1. So I go to my function f of x, and I'm going to replace everywhere I see x, I replace that by t minus 1. So then I'm going to get g of t is equal to t minus 1 over 2 times t minus 1 plus 3 plus ln of 5 times t minus 1 plus 1. Okay, let's simplify this g of t a little bit. So how do we simplify this? Well, t minus 1 over, distribute that on the bottom, you get 2t minus 2. 2t minus 2 plus 3 is 2t plus 1. So on the bottom, I get 2t plus 1. Plus ln, distributed the inside as well. So I get 5t minus 5 plus 1. So that's going to be 5t minus 4. Actually, can you guys change this to, I don't think the center is going to work. Why don't we change this to 7, please? 5x plus 7. So that's going to be plus 7 there. So that's going to be 5t plus 2. Yes. Minus 1 is going to have some problem there. So change to 7. Okay. All right. Now, so I need to find it. What kind of series am I fighting here for g of t? Am I fighting Taylor series or Maclaurin series for g of t? What kind of series am I fighting? Maclaurin. Yes, Maclaurin series. So now this one is almost ready, but I need to split them apart. So I'm going to split this apart into t over 2t plus 1 and minus 1 over 2t plus 1. What about this ln, guys? This ln is, we did the same manipulation with it in class, right? We need to factor out the 5 inside and split them. So we're going to get plus ln of 5 plus ln, that should be plus 2, plus ln, factor out of 5, what do you get? Sorry, factor out of 2, not the 5. We want the 1 there. Factor out of 2. So it's going to be 1 plus 5 over 2t. Right? The same manipulation that we did in class in the example last time. Does that make sense so far? Okay. All right. How do we take care of this? How do we find a series expansion of this? We need to factor out 2 on the bottom, don't we? Actually, we don't. Sorry, I apologize. We don't. Let's rewrite it as 1 plus 2t. Which formula am I going to use here for this series? Which number? which number am I using for this power series? Which basic series am I using? Number 1, right? Yes, number 1, except I replace t by what? Let's go back to number 1 again. So number 1, I have 1 over x minus 1. So in my problem, what do I have? In my problem, I have 1 plus 2t. So here I need to replace t by what? T is replaced by negative 2t. Does that make sense? Okay. So the formula becomes sigma negative 1 to the n, 2 to the n, t to the n. Am I making sense so far? Okay. N start from 0 to plus infinity. And then don't forget to multiply this t by, or the series by t. So that power will simply be t to the n plus 1. Am I making sense so far? Okay, do the same thing to the second series. So the second series is 1 over 1 plus 2t. So almost the same, except I'm not going to multiply by t. So that power will simply stay t to the n. So let me just copy this series right here. And that power stay t to the n. Agree? Am I making sense so far? Okay. For this series, I don't worry about the ln of 2 is just a constant. For the series of ln, which number am I going to use? Which number? Number 5. Am I right? Number 5. Do you guys see that? So for number 5, I get 1 plus x. Okay, let me copy this so that we have it in front of us. So I'm using number 5 here for the series for ln. Okay, what do I need to replace x by here to get that? What do I need to replace x by? 5 over 2t. Am I right? Does that make sense, guys? 5 over 2t. Okay, let's do that. So ln of 1 plus 5 over 2t is equal to sigma n from 1 to plus infinity minus 1 to the n minus 1 over n, 5 to the n, 2 to the n, t to the n. Remember that we always want to split them apart. Okay, so now that I got all 3 series expansions of these 3 functions, let's plug them in. So g of t is equal to ln 2 plus the first series right here minus this one, which is that series right there. So minus this series, just copy that, plug it in. And then plus the last series for ln, which is this one right here. Okay, so plus this last series for ln. Am I making sense so far, guys? Do we understand each other? Any question up to this step so far? Okay, now the next step is something that is new to us, so please pay attention. We need to combine series. And when we combine series, there are a few requirements that must be met in order for us to combine a series. Now, if some of these requirements are not met, you cannot combine them. There's no fix for that. Some of them, if they're not met, in some cases, you can do some fix. And some of them, even if they're not met, in all of the cases, you can fix them. So it doesn't matter if they're met or not. You can always fix them. And the three conditions are center. If you have different center, that's it. You cannot combine them. Different centers cannot be combined. That's it. You don't do anything to it. There's nothing you can do. Next, the exponent. Sometimes you can fix. We can fix sometime if they're not the same. Not all the times though. Okay, we can fix sometimes. And lastly, the starting index. This we can fix all the time. Can fix all the time. So let me explain in this problem. So the center, they have to be the same. If the centers are not the same, that's it. There's nothing we can do. If the exponents are not the same, as you can see in this example, sometimes we can fix, but sometimes we cannot. For example, if you guys see t to the 2n plus 1 and t to the 2n in some of your series, they're not the same exponent. Unfortunately, in this case, this cannot be fixed. Can anybody tell me why this cannot be fixed? If you see the power t to the 2n plus 1 and t to the 2n in your series, they cannot be fixed. They cannot be made the same. Can you explain why? What kind of number would 2n plus 1 be, guys? What kind of number is 2n plus 1? It's an odd number, isn't it? And what kind of number is 2n? It's an even number. So that's it. There's no way. There's no way to make an odd number to become an even number. What about the starting index? Imagine that one of the series starts from 1. One series starts from 1, and the other one starts from 5, let's say. But how do you make them start the same place? Well, very easy. Simply isolate the first 4 from the first series, and then start the first series from 5. Okay, then isolate the first 4 terms in the first series and start it from 5. Then the 2 series will start at the same place. So that's why even they don't start at the same place, they can always be changed to start at the same place. Okay, let's take a look at what kind of series we have here. So let me copy this function g of t down. Okay, center. I have three series here. Do they have the same center? Yes or no? Do these three series have the same center, guys? Yes or no? Yes, they do. Center is 0, 0, 0. So they do have the same center. Now, however, look at the exponents. This is n plus 1. This is n. This is n. They're not the same. So I have to change them to make them the same. By the way, between the starting index and the exponent, you always fix the exponent first. Fix exponent first. Always fix the exponent first. Fix the starting index at the end. Okay, so to fix the exponent, I have to make this to n. And the way I'm going to do that, I'm going to replace n by n minus 1. Are we following so far, guys? Because if I replace n by n minus 1, then n plus 1 becomes just n. I can replace n by n plus or minus an integer. But I cannot replace n by 2n. I cannot replace n by 5n over 11. I cannot do that. N is an integer. So it can only be replaced by another integer. So n can only be replaced by n plus 5, n plus 7, or something like that. Okay? So if I do that replacement, what am I going to get? So let me copy this down again. If I do that replacement, and I'm going to get equals, everything else stays the same, except this n now becomes, this n plus 1 becomes n, and the rest of them also need to be replaced. So I replace n by n minus 1, so this power becomes negative 1 to the n minus 1, 2 to the n minus 1. Now this needs to be replaced as well. Instead of n minus 1 start from 0, I have to do, sorry, instead of n start from 0, I have to do n minus 1 start from 0, which means n starts from 1. N minus 1 equal to 0, that means n equals to 1. Does that make sense so far? Okay, after I have fixed that, look at the exponents. They're all the same now. That's good. I fixed the exponent. Let's go to the index, the running index. Unfortunately, they're not the same. This is n equals to 1, this n equals to 0, this is n equals to 1. They're not the same. So I have to fix them, change them, make them the same. So I changed this. This one start from 0, so I'm gonna pull out the first term and then start it from 1. Okay, so this is gonna be equal. Let me copy this series again. Okay, so when n equals to 1 in here, what do we get? Sorry, when n equals to 0 in here, what do we get? N equal to 0, minus 1 to the 0 is 1, 2 to the 0 is 1, t to the 0 is 1. So I get 1. So when n equal to 0, I get minus 1. So that's what I'm going to get. Let me move this over here a little bit. So I have simply another constant in the front, ln of 2 minus 1. And now that series can start from 1. Does that make sense? Once again, I want this series to start from 1. It is starting at 0 at the moment. So how do I start it from 1? I isolate the first term. The first term is when n equal to 0. When n equal to 0, I get 1. So I isolate that 1 out. Don't forget there's a minus in front, so that actually is minus 1. So I isolate that minus 1 out, and then I start a series from 1. Does that make sense so far, guys? Do we understand each other? Okay. Any question up to this point? Okay. All right. Now we're done. They start at the same place. They have the same exponent. And they have the same center. So we can combine them into one series. So this is equal to ln2 minus 1 plus sigma n from 1 to plus infinity. So simply combine all the coefficients together. So I get negative 1 to the n minus 1, 2 to the n minus 1, minus negative 1 to the n, 2 to the n, and then plus negative 1 to the n minus 1, 5 to the n over n, 2 to the n, and everything, of course, is being multiplied by t to the n. Right? So once again, I'm simply combining the coefficients. So the coefficients are here. I simply isolate the t to the n, or factor out t to the n, if you will. Does that make sense? Are you following, guys? Okay. All right. Now we're almost done. We need the IOC of this. So let's go back to our series that we did earlier. What was the IOC of this first series? Remember, we replaced t by 2t. And according to formula number 1, t was from minus 1 to 1, replaced it by 2t. So now t is between minus 1/2 and 1/2. The same thing with the second series. Okay. What about this last series here? Well, the IOC was originally from minus 1 to 1. I replace x by 5 over 2t. Okay, let's do step by step. So I get minus 1 is less than 5 over 2t, which is less than equals to 5 over 2. Am I right? That's what I did. I replace x by 5 over 2t. Okay, solve for the IOC. So I'm going to get negative 2 over 5 is less than t. Oh, that should be a 1. I'm ahead. One step ahead of myself. That's going to be less than equals to 2 over 5. Does that make sense, guys? Okay. Now let me highlight the IOCs. We have 3 of them. So let me ask you, what do you think is going to happen? Which ones are we, or what is the IOC if I combine the 3 series together? The IOC will be the smallest of the 3, of course, because it needs to satisfy all 3 of them. Okay, so do you guys understand that 1/2 is 2.5 over 5? This is 2 over 5, right? So let me draw the interval out really quick. So I have minus 1/2 and 1/2, okay? So let's say this is minus 1/2. That's 1/2. Those are the first two from the first two interval of convergence from the first two series. And then the last one is -2/5 to 2/5. So 2/5, I hope you understand, is somewhere here, a little bit to the left of 1/2. 1/2 is more than 2/5. Am I right? Does that make sense? Okay. What about negative? What about -2/5? Where's -2/5? To the left of -1/2 or to the right of -1/2? So you're saying that -2/5 is here? Somewhere here? Okay, let's do decimal. -1/2 is -0.5, right? -2/5 is -0.4. Yes, so it's going to be on the right. So was this a circle or not? I forgot. Circle, okay. Yes, so that's going to be a circle. -2/5. Am I making sense so far, guys? So what is the smaller of the three? Or what is the smallest of the three? Clearly, this one is the smallest. So that means my interval of convergence is from -2/5 to 2/5. It's always the smallest one that you need to use when you combine your series. Does that make sense so far, guys? Okay. All right. We are almost done. There's only one last step we have to do. If you remember, we have to go back and replace t by x plus 1. Okay, so let's do that. So replace t by x plus 1. So I'm simply going to copy the series here and just replace t by x plus 1. So my f of x will be equal to this series right here, except t is replaced by x plus 1. What is my interval convergence now? So instead of t between -2/5 and 2/5, x plus 1 is between -2/5 and 2/5. Does that make sense, guys? Okay, so from here, subtract 1 from both sides. What am I going to get? What am I going to get? -7/5 is less than x is less than equals to -3/5. Agree? Okay, and that's the end. So you are expected to do a problem similar to this on the final exam. Once again, what is the idea here? You're gonna get basically the same function, guys, with different numbers that are changed, of course. So you could even make up another example for yourself very easily. Just put some other number here and here, and put other number here and here. Okay, and then you can change the center too if you like. So the idea is we need to replace first to make it into a Maclaurin series, and then split this apart, factor that, use formula number 1 for the first two after we split, use formula number 5 for the ln, get their respective intervals of convergence, choose the smallest interval of convergence from those three, change the power to make sure that the powers match. Here, the centers are the same, so change the powers to match them. After you match the power, now you match the running index. Make sure they start the same place. So if one of them starts 0 and you want it to start at 1, you simply take out the term that starts at 0. So that means just basically plug in n equal to 0 and just isolate that term out. In this case, they have -1. And after they have the same power and the same starting index and the same center, of course, you simply have to combine them. Just factor out all the coefficients and then t to the n. Don't forget to go back to x plus 1 at the end and change also the interval of convergence. Does that make sense? Okay. So something like this will be on the test. Also, there's something that I need to clarify as well. So let me go back to the final exam information. I wrote about this before. So there are some small changes. This range is from 30 to 40%. This range is from 60 to 70%. The reason is they don't have the same number of problems. There's not 4 and 6. So I need some room to work on the numbers a little bit. So that's only the approximate percent, but they should be in that range. Also, I believe I told you guys that if you do better on the final exam, I would replace your midterm score by the final exam. However, I make a small mistake on the midterm. If you remember, which one has the heavier percentage? The first or the second when you took the midterm? The first, right? The first part. The first part of the midterm is about 60 to 70%. I believe I told you that. And the second part of the midterm was about 30 to 40%. I would change that on the canvas. Now, so they should not be worth the same amount of points. However, when it comes to the final, things got switched up a little bit. So the first part of the final exam now is worth only from 30 to 40%. And the second part of the final exam is worth from 60 to 70%. So that means when I replace them, they have to be zigzagged a little bit. Does that make sense so far? Okay, so the second part of the final exam will actually replace the first part of the midterm exam. Okay, so make sure it's clear here. So this is the midterm on your left, and that's the final on your right. So the first part of the midterm exam replaces the second part. The first part of the final exam replaces the second part of the midterm exam, and the second part of the final exam replaces the first part of the midterm exam. Are we clear on that? Okay. Of course, everything else stays the same. Got it? I told you that the first part of the final exam has how many questions? Did I tell you guys that? Does anybody remember? 5. That's correct. So let me write them down here again. Yes, here. So have 5 questions on the first part. 5 questions. 3 of them are going to be integrals. Applications of integrals. Okay. And did I tell you about the second part? How many questions on there? No. Let me count. 1, 2, 3, 4, 5, 6. You have 6 questions on the second part. They're all series. They either a series of numbers or power series. Okay. And I gave you one of them already. So basically I gave you one of them already. No, wait, let me count it again. 1, 2, 3, 4, 5, 6, 7. I apologize. 7, not 6. 7 questions on the second part. And I gave you one of them already, which is the one we just did today, basically. Different numbers, of course. Does that make sense? Okay. All right. And for each part, you can bring a note card 4x6, only one side. You can bring a scientific calculator if you like. Okay. Perfect. All right. So now is the time that I will answer any questions. You can tell us which topic we should focus more on the first exam. No, because I want you to know everything. So cumulative, I will not tell you what to focus more. Yes, the lowest quiz score will be dropped. Mm-hmm. What happens if when doing a problem about volume rotation, you get a negative answer, but the number is correct? Well, you're going to lose some points. You're not going to lose the whole problem, but you will lose some points. We are planning to be tested on the final since it wasn't on the midterm. Yes, all the applications are eligible now for the final exam. Midterm 2, question 3. Midterm part 2, question 3. Okay. Are you asking for the solution to this problem? Okay. So on the midterm 2, question 3, I have find the volume of a solid generated by rotating the region bounded by x equals y minus 3 square, x equals to 4, and the rotation is about y equals 1. All right. So what's the first thing that we do here? No, even before that, we don't check for x, y, or x convenience yet. Go back to your notes, please. If you're not rotating about x or y axis, which you are not in this case, yes, you have to replace y by y plus 1 first. So replace y by y plus 1. Okay, so I'm going to get x is equal to y plus 1 minus 3 is y minus 2 square. X equal to 4 stays the same, but the rotation now is about y-axis. Sorry, about y equals 0, which is x-axis. Okay, now is the time you test for xy or yx convenient. Which one? It's actually both, but I prefer not to do with roots, so I'm going to do it as yx convenient. Yx convenient about x-axis. Am I right? So after I determine that, what's the next thing that I need to do? Yx convenient about x-axis. What's the next thing I need to do? Formula. Thank you. V equals. Is this the one with 2 pi or with pi? 2 pi. Thank you. 2 pi integral, because it's yx convenient, that means the limits are for y. So going to be from y1 to y2. Y times x2 of y minus y times x1 of y dy. Okay, now it's time I find the limits for y, which I need to be doing using the 4 steps. Steps 1 say look for equation y equals a constant. There's nothing like that from the problem. Step 2 say to equate the two solutions. So I get y minus 2 square is equal to 4. This implies that y minus 2 is equal to 2, or y minus 2 is equal to minus 2. From here, I get y is equal to 4, or y is equal to 0. Now, you guys have to be careful. Y equals to 4 and y equal to 0. You need to make sure that these two are not symmetrical with your axis of rotation. Your axis of rotation is the x-axis, which is y equal to 0. Okay, that's good. These two are not symmetrical. But imagine that at this step, you get the limits for y to be -2 and 2, which is going to be symmetrical, right, about the axis of rotation. And you wouldn't choose both of them. You choose only one of them, okay? So in this case, I choose both because these two are not symmetrical. So from there, I get what? Volume is equal to 2 pi. Integral from 0 to 4. Okay, now's the time I need to plug in. Let's say y equals to 1. Y equals to 1. That's 1. That's 4. So this, and then multiply by y, which is 1. So 1 times 1 is 1. 4 times 1 is still 4. So this is the bigger one. So it's going to be 4y minus y times y minus 2 squared dy. And I will stop here because that integral is trivial. Am I right? You distribute and combine line terms, integrate them one at a time. Does that make sense? Okay. All right. What's the other question? I see there's one more. Section 6.2, question 51. All right, let me get the textbook. So I'm not sure if they still use the same version here. So let's see. Which one was it? 6.2, 51. Okay. As you can tell, I have very bad memory. I just read it, but I forgot it. So I don't like to memorize stuff. But I have to in math. There are certain formulas I just have to memorize. And I hate memorizing, but I have to do it. Otherwise, there's no way to survive. Which one was it again? 6.2, number 51. Okay, let's take a look. That's an integral, I believe, right? 6.2, 51. So I have integral I is equal to integral of the square root of x squared minus 9 over x cubed. Agree? This is 1. Okay, dx. Okay. Well, there's several ways we can do this problem, but nothing wrong to put the radical on the bottom. Okay, you put the radical on the bottom, what are you going to get? Integral of x squared minus 9 over x cubed times the square root of x squared minus 9 dx, right? Rationalizing, put the root on the bottom. Okay, and split them. So I'm going to get integral. Well, when I split these, I'm going to get x on the bottom, but I don't want x on the bottom, so I'm going to put x to the minus 1 on the top, divided by square root of x squared minus 9 dx. And the other one is negative 9 integral. I have x cubed on the bottom. I don't want it to be in the bottom. I'll put that back on the top. X to the minus 3 over the square root of x squared minus 9 dx. Okay, does that make sense so far? All right, so what is the next step? This is a binomial integral, obviously, right? So let's solve one of them at a time. Solve this one. Help me, please. First guess. Everything under the radical is u. Its derivative is 2x. Well, if I want that derivative on the top, I have to put x here. And then that will become power negative 2. Which is friendly to my substitution. But I told you guys, don't stop there yet, right? Check all the choices really quick. Okay, so I know if nothing else works, the first guess worked. Okay. All right, continue to go to the next one. Second guess is when this when x is equal to u, but that makes no difference. That just changed name, so it's not going to work. Before I can do the next two guesses, I need to take out the highest power. So take out the highest power on the bottom. That's an x outside. That becomes x to the negative 2 now on the top. Divided by square root of 1 minus 9 x to the negative 2 dx. Am I right? Do you understand so far into this step, guys? Okay. All right. Then what's going to happen after this? Well, guesses. And u, everything under the radical is u. That's not going to work because the derivative is x to the negative 3. If I want x to the negative 3 there, then this has to become x to the power 1. So that's not friendly to my substitution. However, did you guys notice that this is formula number 11? What is u? U is 3x to the negative 1. You guys see that? So this is number 11. Formula number 11. See how quickly I recognize it? I couldn't even remember a problem for a few seconds, but I memorized my formulas very well. Because I memorized them so well, I can recognize them right away. So u is equal to 3x minus 1. What is u prime? Negative 3x to the negative 2. That's exactly on the top. I'm missing a negative 3, of course. So multiply by -3, divide by -3. Does that make sense so far, guys? Okay, so I will stop here, right? Brian, do you understand what to do from here? For the first integral, okay, that's just number 11. Let's go on to the next one. What's the next one? This is the next one. All right, let me copy that. Okay, let's solve this. Make sure you multiply by -9, of course, at the end. Okay. Same thing, we make guesses. The first guess, everything that the radical is u. That means u prime needs to have power x to the power 1. So that should become power -4, which is even. So it's going to be friendly to my substitution. So if everything fails, number 1 works. But I'll come back to that in a second. I need to check the other guesses. All right. Second guess, x equal to u. Nah, nothing. I don't see anything there. Pull out the highest power. So that's going to be x to the -4 over square root of 1 minus 9x to the -2 dx. Okay. All right, let's see what's going to happen here. So first guess, everything under the radical is u. So that means I need to have x to the -3 to be my derivative. But if I have x to the -3 there, this has to be x to the -1, which is not friendly to my substitution. I need an even power. So that's not going to work. Okay. And the second guess would be u to be equals to what? U to be equals to 3x to the -1. Its derivative is x to the -2. So x to the -2 there. And then this needs to be x to the -2 as well. Yeah, friendly to the substitution. Nothing wrong with that. So which one would you like to do? So 1 and 4, they both work. Which one should I try? In the moment, I don't see which one is easier. Yeah, I cannot see that so far ahead of myself. Okay, let's try 1. Okay, let's do guess 1. See how that's gonna be. Okay, guess 1. Say u is equal to x squared minus 9. So u prime is 2x. From here, x squared is u plus 9. Okay, so let's see what I need. So I need a 2x here. So that's going to become x to the -4. And then divide both sides, divide outside by 2. Okay, so I need x to the 4th. So if x squared is u plus 9, that means x to the 4 is u plus 9, the whole thing square. Am I right? Are we following, guys? Hello? All right, thank you. So this is equal to 1/2. So x to the -4, that just means it goes on the bottom, right? So which is 1 over u plus 9 square on the bottom. Okay. So integral. So what I get on the top, I get du on the top divided by u plus 9 square times the square root of u. Agree? Okay. Now what do I get? I get a radical. This radical is getting in my way. And if you remember, if you see an integral with radical, the first step, the first thing you should always try is to see you can get rid of it. And I told you that you cannot do that in general. You can only get rid of roots if the quantity under the root is what? Linear or bilinear. Am I right? You guys remember that? Okay, in this case, this is linear. So let's say make substitution u equal to square root of u. T equals square root of u. From there, t squared equals to u. This implies that du is equal to 2t dt. Okay, plug it in. This is equal to 1/2. Integral du is 2t dt. U is t squared, so t squared plus 9 squared, and the square of u is just t. T cancel, 2 cancel. That's just integral of dt over t squared plus 9 squared. And how do you solve this? How do you solve this integral, guys? He just passed away a couple of days ago. Yes, the Pope. Am I right? This is the Pope. Agree? Okay. Yes. Does that make sense? Okay. So, Brian, I can stop here, right? You understand what to do? Okay, good. Perfect. Again, try number 4 to see if it's easier. I mean, I would be satisfied with this because I know all the methods here, so I can get to the answer no problem. So for me, this may be longer, but it's very palatable. All the methods I know. Maybe number 4 is going to be a little bit shorter. I don't know. So we'll give it a try. You guess 4, I meant. Okay. All right. See, I told you that there may be cases in which some of the methods, especially trig substitution in the textbook, could produce some shorter solutions. Don't get me wrong, but that's not the case in general, because I told you that there are some problems that if you follow what I teach you, you can solve using the binomial integral approach. But trig sub, not only that's going to be long, it's going to be impossible to solve those integrals. Trig subs can only solve a portion of the class of integrals that is addressable by binomial integrals. Okay, so it's like, what should I teach you? If you need to remember one method for solving the quadratic equation, are you going to remember factoring, or are you going to remember the quadratic formula? Which one? Which one? If you have to retain only one method of solving quadratic equation, would you retain factoring or would you retain quadratic formula? No, of course not factoring. Not factoring, because it does not work all the time, guys. Not all quadratic functions can be factored. No way. If you only remember factoring, it's going to be hopeless when it comes to real life, because real life quadratic equations are not factorable. Write out a random quadratic equation using random coefficients A, B, and C. What's the probability that they're going to be factorable? And not only that, nicely into integers. That's impossible. So factoring is not a method you should retain, because it's really is inferior. It could be faster in some cases. Yes, don't get me wrong. It is faster in the case that the quadratic is factorable. It's going to be faster than using the quadratic formula. But that's not a good method, because it doesn't work all the time. If you remember only that, you're going to be handicapped when it comes to solving the quadratic equations, because your method will not work all the time. No. So if I go to class and teach you to factor only quadratic equations, and then on the test give you problems that can be always factorable, I'm lying to you. Actually, I'm not doing you a good service. I'm lying to you. You understand that? You would believe that, oh, everything is going to be factorable. That's not the case. Does that make sense? So by teaching an inferior method and examining by giving inferior problems, for me, it's like lying to the students. Okay, so don't do that. Exam 1, part 1, question 4. Let me see. Talking about the midterm exam, right? No, that's a formula. That's not binomial integral. You see how quickly it is for me to recognize it's a formula? It's not that I memorize this problem. I just look at it a couple seconds and I recognize the formula right away. Do you guys realize that u is equal to rad 2 x to the 7? Right? So it's the u prime is going to be 7 rad 2 x to the 6, and that's on the top. Formula number 11. Thank you. Yes, that's formula number 11. So that's not a binomial integral approach. You could be. I mean, this is actually your second guess. Am I right? If you go down with binomial integral approach, you're gonna identify this anyways with a second guess, right? But this should be thought of as a formula. Okay. So what I'm teaching you are very much integrated, guys. It's not just 1 and 2 tricks separately. Everything is integrated together, and the theory is very strong and connected. All right. Can you explain the last two formulas, handout number 6? Yes. Before I explain them, I just want you to know that they're not going to be tested. 6, 7, and 8, these will not be on the final exam. Well, they're basically the same, right? You have just different functions. However, the only thing that is missing is the double factorial. You guys know that factorial skip by one number, right? For example, 7 factorial is 7, 6, 5, 4, 3, 2, 1. But what about you have 7 double factorial? Double factorial means that you skip by 2. So that's going to be 7 times 5 times 3 times 1. Similarly, 6 double factorial is equal to 6 times 4 times 2. Right? It is explained down here. You guys see that? Skip by 2. And that's basically the only difference. Okay, and then you have something called the generalized binomial coefficient. This is the so-called combination that you guys learned before, right? Let's say 7 choose 5 or something like that. You would use what? 7 choose 5 would be equal to 7 factorial divided by 5 factorial times 7 minus 5, 2 factorial, right? But what's going to happen if your number here on the top is just not an integer, but it's alpha? Well, alpha is not an integer, then you would need this formula here. So that's just a generalized binomial coefficient. So for example, you can try 1/2 choose 5, for example. Then in that case, alpha will be 1/2, and then you plug it into here, and then you calculate that. And you need that for this type of series here. Does that make sense? So 1/2, for example, if alpha is 1/2, then you would get 1 plus x to the 1/2. Then a series expansion of that would be this. But they're not going to be on the final exam. The last 3 formulas. As I said, study the one I did today. Yes. Hmm. Right. Okay. Very good. Okay. So I will have more review next Monday and Wednesday online. So I'll send you a link just like today. So please come back if you have any questions. Okay. And you have your first part tomorrow for the final exam. Good luck. I'll see you next week. Right.